We're going to start the ACL section off with a little bit of a personal note from yours truly. One of those things I like to mention from time to time is something that I really wish someone had told me when I was studying for the CCNA. And here it's the importance of access lists. Now I know you're going to learn these, I know you're going to study these because they're going to be all over your exam, but you need to master the fundamentals of ACLs not just for your exam, but for real world networking. You can't let your knowledge of ACLs slide after you pass the exam, because ACLs, of all the features you're going to learn about in this course that you've already hit and that you're going to, they're likely the most commonly used feature in use today. And what we're going to do here is use them primarily for permitting and denying traffic based on the source and or destination IP address. And of course that's a common usage for ACLs, but another very common usage is to use ACLs to identify traffic for other Cisco features to take action or not take action on. Now you're not going to see that much, if at all, in your CCNA studies, but you'll see ACLs used for traffic identification regularly when it comes to your NP studies, as well as any security studies. If you're getting your CCNA security certification, which I urge you to do, you are going to have to know ACLs inside out. Great thing is you're going to find that regardless of what ACL type you're actually using, the rules are really the same. They don't differ from one ACL type to another, and we'll take that every time we can get it. Now this particular video and the next one going to be a little rule heavy and a little theory heavy, but I have plenty of labs coming up. This may actually be the biggest section in the course because I have a lot of ACLs I want to show you in a lot of different uses. But we gotta know the rules, and beginning with the two rules, the biggest rules of the ACL jungle. The first one being that every ACL has what we call an implicit deny at the end of it, or at the bottom of it, if you will, because our ACL is going to be lines, and of course, set of lines always got to have a top, always got to have a bottom, and it's got that implicit deny. More about that in a moment. Another rule is that the ACL searches for a match beginning with that top line, and when a match is found, that's the end of the search. Now with the routing table, the IP routing table, we've talked about how we're looking for the best match and when the administrative distance comes into play, that kind of thing. But with an ACL, we're not looking for the best match, we're looking for a match. And when a match is found, if you have a 20-line ACL, if a match is found on the first line or the 19th line, that's it. So we've got to be very careful about the order of our lines. More about that coming as well. Now, again, I'm going to show you a standard ACL in a moment, and if you've never seen one or you don't even know what a standard ACL is, don't sweat it. But I want to show you an example of one now, because when a packet enters or exits an interface that has an ACL applied, at least one value on that packet is compared against the ACL, again, on a line-by-line basis. And generally speaking, it's going to be the source IP address or the destination IP address or both. We can use all kinds of other values, and we'll see a few of those, but those are the main two we're concentrating on right now. And here's an example of a standard ACL. And if you're not familiar with the syntax here, no problem at all, because you will be. But what I want to impress upon you right now is that each one of these lines matches one IP address exactly. The first line matches 10.1.1.1 exactly, then the second line 10.2.1.1 exactly, and so forth. So this is an ACL that I could write in a lab, and if I did a show command, it would show me this list, but it would not show me anything else. And you might be thinking, well, Chris, why would it show you something else? That's all you wrote. Well, that's where the implicit deny comes in, because here we have a standard ACL. And one thing about standard ACLs, I'll get a little ahead of ourselves here, they can only match on the source IP address of a packet. That's it. It's very standard. We don't have a whole lot of options here. So again, the first line there matches a packet with a source IP address of 10.1.1.1, second line 10.2.1.1, and so forth. So let's say we apply it to an interface on this router, and the packet coming in has a source IP address of 100.111/24. Well, there's no way that a packet with that address is not matching any of these four lines. So what happens when we have no matches at all? Well, again, it goes line by line. It's going to look at line 1 and say, okay, is this a match or not? Then line 2, is this a match or not, or so forth. And if there is no match, then it just keeps going down one line at a time until there are no lines left. That's where the implicit deny comes in. The implicit deny, it's really an invisible deny. Don't call it an invisible deny in a job interview. But it's really an invisible deny that's at the bottom of your ACL. And you won't see it when you run show IP access list. You won't see it when you run any verification command, but it's there. So since you don't see it, it's easy to forget about, especially when you're new to ACL study. So be kind to yourself on that. Don't kick yourself too hard if you miss it the first time around or you forget about it the first time around. But after that, you got to remember, hey, there's always a deny any at the bottom. Because I tell you, of all the little things that can go wrong with an ACL, the implicit deny, forgetting about it, is the #1 reason that an ACL is not giving you the desired results. Now, coming up next, you might want to grab something to write with here because we're going to talk about wildcard masking. I'm going to show you how to make it very easy. Wildcard masking, you're going to use it with access lists. You're going to use it with EIGRP. You're going to use it with OSPF. So we've got to know it inside and out. We're going to take a few minutes to hit that on the next video, and then after that, we'll start getting into some lab work. See you there.